Okay, I recognize not everyone is finished, but I'm going to go ahead and start anyway. So I'm recording. This is problem 2015, question 6, and it's a tortilla problem. So corn tortillas are made at a large facility that produces 100,000 tortillas per day on each of its 2 production lines. The distribution of diameters of the tortillas produced on production line A is approximately normal, with a mean of 5.9, and the distribution of the diameters of the tortillas produced on production line B is approximately normal with a mean of 6.1. So we have 2 normal distributions, one with a mean of 5.9, another with a mean of 6.1, and that's kind of what they've shown here. All right, so we have 2 normal distributions, and that's the way they're centered. And the figure below shows the production line, the distribution of the diameters for the 2 production lines. And we're getting 100,000 from this one and 100,000 from that one. The tortillas produced at the factory are advertised as having a diameter of 6 inches. Well, that's interesting because this one has an average of 6.1 and this has an average of 5.9. For the purpose of quality control, a sample of 200 tortillas is selected and the diameters are measured. From the sample of 200 tortillas, the manager of the facility wants to estimate the mean diameter in inches of the 200,000 tortillas produced on a given day. 2 sampling methods have been proposed. So here they are. Method 1. Take a random sample of 200 tortillas from the 200,000 produced on a given day. Measure the diameter of each selected tortilla. So that's interesting. So we're going to take a random sample from all 200,000. Well, if I do that, I should end up with a distribution that looks about like this, because ideally my sample will look like the population. So method 1 should give me something that looks about like this, about like the population. I know that doesn't look like a 1, but that's supposed to be a 1. Method 2, randomly select one of the 2 production lines on a given day. Take a random sample of 200. So we have the same size at 200 from the 100,000 tortillas produced by the selected production line. Measure the diameter of each of the tortillas. So method 2 is going to look like this. They're either going to select production line A and end up with 5.9, or they're going to select B and end up with 6.1. And if you note, well, we'll come back to this later as we go through. So those are our 2 methods. This will be method 2. This will be method 1. We'll look something like this. Will a sample obtained using method 2 be representative of the population of all tortillas made that day with respect to the diameters of the tortillas? Explain why or why not. Well, method 2 is either going to be either going to be B or it's going to be A. It's not going to be both. Well, that does not look like the population. So very simply, that answer is no. A sample obtained using method 2 will not be representative of the population. Make sure you always answer the question they ask. So make sure you always don't just describe what's going on. Make sure you answer the question they ask. Well, I answered it, but now I need to justify it. And they asked me to explain it. They don't always ask me to explain why. I don't care if they do or don't. You always must explain it. Because basically I had a 50-50 chance of guessing this. I'll get no credit if I just write this nice little sentence there will get me no credit if I don't back it up. And I'm sorry, I shouldn't be into that section of the rubric, but anyway, you got to back this up. So the population of tortilla diameter center is at 6 inches. And you're like, well, how did you say it was 6? Oh, the population is at 6. This one's at 5.9, this is 6.1, but the average of the entire population will be right in the center at 6. And ranges from 5.7 to 6.3. And you're like, how do you know that? Well, that's about where it went to, from 5.7 to 6.3. And the shape is bimodal with peaks at 5.9 and 6.1. Well, that's the population. If method 2 were used, the resulting sample would be mound shape, in other words, not bimodal, with the center at 5.9 and ranging from 5.7 to 6.1. Or it would be mound shape with a center at 6.1 and ranging from 5.9 to 6.3. Method 2 would only represent one of the production lines and not both. Okay? So we need to make sure that we're making a comparison of why the population would be different than what we would get if we use method 2. Extremely important to do that. All right, moving on. Part B. The figure below is a histogram of 200 diameters obtained by using one of the 2 sampling methods described. Consider the shape of the histogram and explain which method, method 1 or method 2, was likely used. Well, while this isn't while it's not a beautiful curve, I can look at this and go, you know what? 2 peaks, bimodal. And we already said when we read this thing that method 1 would be the one that gives us 2 peaks. So I'm guessing that this is method 1. So method 1 was used to create this histogram. This can be concluded because the histogram shows the bimodal characteristics of the population and is centered at a diameter of 6. Once again, here's where I think the mean is approximately, and has a range similar to that of the population. Method 1 represents both production lines of the population, whereas method 2 would have only represented 1. So this one's representing 2 distinct, and this is only representing 1. And while I didn't do this, I'm going to tell you that your grader would probably like it if you had labeled this production line B and line A. Are they going to give you extra credit for that? No, but that's something they're going to like to see because they're going to know that it's like, hey, I understand what I'm looking at. I'm looking at 2 distinct groups. Part C. Which of the 2 sampling methods, method 1 or method 2, will result in less variability in the diameters of the 200 tortillas in the sample of a given day? Well, that's a really good question. So let's go back and look at what that drawing was that I put together. Originally, we said this would look like method 1, and these 2 together would look like method 2. And they're asking about variability. Well, one measure of variability, or one of the easier ones to see, is the range. Well, look at the spread of the data for method 1. For method 1, I have a spread that goes from 5.7 to 6.3. If I choose method 2, and let's say I end up with production line A, I'm going to go from 5.7 to 6.1, much shorter. Or if I had method B, it would be 5.9 to 6.3, again, much shorter. So for a given day, for any one day, method 2 would result in less variability. So for a singular day, method 2 would result in less variability. Method 2 represents only one production line, while method 1 represents both of the production lines. Method 1 will result in a sample range of approximately 0.6, and I showed how I got that, 6.3 minus the 5.7. Once again, that's that 6.3 minus the 5.7. And the ranges of both production lines are 0.4 So method 2 would only have a range of 0.4. I'm going to pause this for a moment. I should have paused it earlier. I'm going to pause this so that y'all can have an opportunity to copy some stuff down. Okay, each day the distribution of the 200,000 tortillas made that day has a mean diameter of 6 inches with a standard deviation of 0.1. So basically all they're saying is each day, here's where the center is at 6, and they're telling me the standard deviation is 0.11, and they know that I have a distribution of 200,000. For samples of size 200 taken from one day's production, describe the sampling distribution of the sample mean. So they want the distribution of the means for samples that are obtained using method 1. This is really important. We have a sample size of 200, which is greater than or equal to 30. So even though the underlying distribution is bimodal, we're going to end up with a normal distribution. So the distribution of the sample means for sampling method 1 will be approximately, please use the word approximately, normal, because the sample size of 200 is greater than 30. So in other words, reasonable by central limit theorem. And really, I probably should have written by central limit theorem, and I'm just going to abbreviate here. Our mean will be 6 inches. It will have no change. And then our standard deviation is going to be the standard deviation of the population divided by our sample size. Well, our sample size was 200, the square root of 200, and then 0.11 was the standard deviation of the population. So I end up getting 0.0078 inches. Now, please remember, they're asking for the distribution of the sample means. And when they do that, that is when I'm going to use that formula. All right, so that's distribution of the sample means is the key phrase for knowing to do that. All right, continuing on. Actually, I'll pause for just a second. Suppose that one of the two sampling methods will be selected and used every day for 1 year or 365 days. The sample mean of the 200 diameters will be recorded each day. Which of the two methods will result in less variability in the distribution of the 365 sample means? Please explain. Well, let's think about this for a moment. And of course, I set my drawing off to the side right when I needed it. Production line A, we just said, would have a mean of 6, whereas this one, method 2, is going to have a mean of 5.9 and a mean of 6.1. In other words, on average, each day, I expect each day to be about 6. Over here, one day I'm selecting A, next day I'm selecting B. So 50% of the time, I'm going to have a mean of 5.9, and 50% of the time, I'm going to have a mean of 6.1, approximately. So this one has more variation just because I have more means, whereas this one is always going to have the same general mean. So sampling method 1 will have less variability because it will have a mean of approximately 6 inches for every one of the 365 days. While sampling method 2 will result in having approximately half of the days having a mean close to 5.9, and the other half having a mean of close to 6.1. Method 1 results in a single peak, whereas method 2 has 2 peaks, indicating greater variation for method 2. So in part F, a government inspector will visit the facility on June 22nd to observe the sampling and to determine if the factory is in compliance with the advertised mean diameter 6 inches. The manager knows that with both sampling methods, the sample mean is an unbiased estimator of the population. However, the manager is unsure which method is more likely to produce a sample mean that is close to 6 inches on the day of the sampling. And I'm just going to take a moment and say unbiased estimator means they know that the sample mean will is a equals the population mean. All right, the sample mean equals the population mean. Based on your previous answers, and this is really key, when you see this phrase, use your previous answers. Which of the two sampling methods, method 1 or method 2, is more likely to produce a sample mean close to 6 inches? I'm just going to go back to my drawing that we had at the very beginning. That's the mean. Whereas this one had a mean of 5.9, so they might get 5.9 or they might get 6.1. This one is very likely to give me a mean of 6. So the manager should choose method 1 because it'll have a mean of approximately 6 inches. It is expected that sampling method 2 will result in a mean of about 5.9 or 6.1, depending on which production line is selected. In either case, the mean is not the desired 6 inches. All right? And just from a logical standpoint, based on what they told you earlier in one of the earlier prompts, they said that the mean of method 1 was 6 inches. So basically, you could actually use that information to help support your answer. All right.
They've got major sections to grade. So the first section that's graded together is parts A, B, and C. D is by itself, and then E and F, the last two, are clumped together. So for section 1, there are 3 main components. If you get all 3 main components correct, you get an E. If you get 2 of them out of the 3 main components, you get a P. And each main component is the parts A, B, and C. So if you get all of A, B, and C correct, that's how you get your E for section 1. If you got A and B, or B and C, or A and C, that's how you get a P. So the things that they were looking for in part A is basically for you to say no and then give a justification for that. Mr. Spencer's justification was more than sufficient. Actually, a lot of the things that he said also be what they were looking for in part B. So if you had that, that was a great argument. You could have simply just said that they have 2 different sample means and 2 different centers, and that would have been enough justification on their part. So if you said no, and then you gave a proper justification, you got part A correct. For part B, they're looking for you guys to recognize the bimodal nature. So you'll have to address that they have, there's like 2 centers going on, or the shape is bimodal. If you address both of those, that is essentially good for part B. For part C, they're looking that you do select method 2 would result in less variability, and then you have to justify why. Mr. Spencer gave a good one about looking at calculating the variability using the range, which is one of the ways that they were looking for that to be justified. Or they also took for a good justification to talk about that the distributions had different centers. And so it would produce more varied data, more varied sample data. So if you had it left it generic like that, they would also count that as full credit. So if you got all 3 parts A, B, and C correct, that's an E for that section. If you got 2 out of the 3 parts, that's a P. For part, that section 1, it did list specifically that they were looking for weaker justification. So this is the part where they don't always say that, but this one they made a point to include that if any of your parts had a weaker justification that was incorrect, that you could not score points for that section. One of the examples that they gave specifically for a weak argument was that if you said that only 1 line was selected because the sample size was too small, that was grounds for a weak argument that was incorrect. All right, for part D, that is its own section. They are looking for you to answer all three parts that says it's approximately normal, the mean is 6 inches, and that you show work for standard deviation. If you left out that it's approximately normal by the central limit theorem, the justification part for that, it did not count against you. You did not have to justify that the mean of the sample was the same as the mean. You didn't have to justify any of those things. And you could still get full credit for that. So if you had all three parts correct, that's an E. If you got 2 out of the 3 things, then that's a P. For your last section, part E and F, that's clumped together into one section. The key thing that they're looking for here is that your sample 1 will have less variability. You could have justified it the way that Mr. Spencer did. And another key component that must be addressed is the fact that method 1 basically has a single peak, where method 2 will have 2 peaks. You didn't have to say it in those words, but the idea that we have 2 different centers happening. So that would get you full credit for part E. And then for part F, the manager should choose method 1. You have to have that selected. And then for your justification, you could have done what Mr. Spencer did and calculated and stated specifically. There's a special note that, guys, if you do not say approximately or about, if you say the mean is 5.9 or 6.1, that is incorrect and you would lose credit for that. So make sure that when we talk about means, and when we talk about normal, we talk about is approximately, is about, close to, you use those kind of language. So because if you imply exactness, then that counts against you. So if you got both parts right, E and F, then you get an E for that problem. If you only got one of those parts, then it's a partial. The way they broke it down is that 3 E's is a 4, 2 E's and 1 partial is a 3. There is a multiple ways to make a 2. And remember that if you're going for a 5 overall, that we're very, very happy for you if you make a 2 on a question number 6. So you could have done 2 E's, 1 E, and 2 P, or even if you just got a partial from each of the sections, that would still earn you a 2. So this is totally doable, guys. We can get there. And then if you had 1 E or 2 P's, that's a 1. Any questions on the rubric?